Right, in this short test we're going to look at the basics of differentiation. We've got y equals 6 plus x minus 2x squared, and we want to find dy by dx. Remember, we're going to use the rule take times by the power, take 1 off the power. And there is no power here, so adding 6 does not affect gradient, so that does not come into the gradient function dy by dx. X is to the power of 1, so times by 1. Take 1 off the power, takes it to 0, x to 0 is 1, so x just becomes 1. Times by the power, so 2 times 2 is 4. Keep the minus sign in there, so we get minus 4. Take 1 off the power, that becomes x to the 1, which is just x. So our answer for dy by dx is 1 minus 4x. Next thing we're asked to find is the coordinates of the turning point. And a turning point, now if we look at this graph here, y equals 6 plus x minus 2x squared, because it's a negative x squared, we know that it has this sort of shape on the curve. And a turning point always occurs where the curve changes from being a positive gradient up to here to a negative gradient here. So the nature of the gradient changes from flattening off and then to getting steeper again. So therefore the turning point is where the gradient is momentarily 0. So dy by dx equals 0. Now if dy by dx equals 0, that means 1 minus 4x equals 0. And so therefore 1 equals 4x, add 4x to both sides, and x will therefore equal a quarter if you divide both sides by 4. Now we want to find y, so we're going to use this equation to find y. We want to find y because we want to find the coordinates of the turning point. So let's put a quarter into this. So you get y equals 6 plus a quarter minus 2 times a quarter squared. Now a quarter squared is 1/16. 2 times 1/16 is 1/8. 1/8 away from 1 quarter is 1/8. So y will equal 6 and 1/8. So our coordinates will be a quarter, comma, 6 and 1/8, or 6.125 if you prefer decimal. State with a reason whether or not the turning point is a maximum or a minimum. Well, I just stated a reason here. It's a negative x squared in a quadratic. So we have a quadratic with a negative coefficient squared. Therefore we have an N-shape graph. Now if an N-shape, that means the turning point occurs at the top, so therefore it's a max. Find the equation of the line of symmetry of a curve. Right, all quadratics have a line of symmetry, and the line of symmetry always goes to the maximum point. And the maximum point happened when x equals a quarter. Here. And notice this is a line that just follows parallel to the y-axis. X equals a quarter. So therefore the line of symmetry will be just simply x equals a quarter. All vertical lines are x equals something. All horizontal lines are y equals something. Simple answer. Find the gradient of the curve when x equals 3. So the gradient was 1 minus 4x. So the gradient, because we differentiate to find the gradient is 1 minus 4x, so we've got 1 minus 4 times 3, that just gives us minus 11. Find the coordinates where the gradient of the curve, y equals 6 plus x minus 2x squared, is equal to minus 7. We know the gradient equals 1 minus 4x, and we want to know where that equals minus 7. So we get minus 4x equals minus 8, taking away 1 from both sides. Divide both sides by minus 4. Minus 4 goes to minus 8 2 times. Minus divided by minus gives us a plus. We want the coordinates, so let's find the y value. And y is given by this expression here. 6 plus 2 minus 2 times 2 squared. 2 squared is 4, times by 2 is 8, and we've got 6 plus 2 is 8, 8 minus 8 equals 0. So therefore, the coordinates where the gradient is equal to minus 7 is 2, 0. Right, in this question, a body is moving a straight line, and it passes through a fixed point O, and the displacement, i.e. the distance from a point, is given by s equals 2t to the 4 minus 3t squared plus 7t plus 4. So if s equals 2t to the 4 minus 3t squared plus 7t plus 4, then the velocity is equal to the differential of that, the rate of change, ds by t. Remember, velocity is the gradient on a distance time graph. And if it's the gradient, sorry, that was to the 4 there, then we must need the differential. So let's differentiate that. 4 times 2 gives me 8t, times by the power, take 1 off the power to get 3. Times by the power gives me 6, take 1 off the power, just leaves me t. Remember, 7t just becomes 7. And the 4 is a number we add on, doesn't make any difference. So the expression for the velocity is 8t cubed minus 6t plus 4. Find the acceleration after 2 seconds. Right, v equals ds by dt. The acceleration is actually equal to the rate of change of the velocity, dv by dt. So we differentiate again. Times by the power. 8 times 3 is 24. Take 1 off the power, gives you t squared. And minus 6t just becomes minus 6. And remember, adding a number or taking away a number makes no difference to gradient. Now we want to find the acceleration when t equals 2, after 2 seconds. So put t equals 2 into this, you get 2 squared, so you get 24 times by 4 minus 6. Well, 24 times by 4 is just 96, minus 6 gives us 90 meters per second squared as our units for acceleration, which is rather high.